Right now, something is happening inside your body that you cannot feel, cannot see, and probably aren't thinking about. Your cells are either burning glucose that ran out 2 hours ago, or they've started reaching for something else entirely. There is a metabolic handoff that happens during a fast, and it runs on a precise biological clock. Miss the timing, and you stay in storage mode. Hit it, and your body starts doing something no drug, supplement, or workout can fully replicate. Here's the honest promise. Fast for 16 hours, just 16, and your body moves through 5 distinct metabolic phases. Each one builds on the last. By the end, you are running on a completely different fuel system than the one you woke up on. A 2019 paper in the New England Journal of Medicine by Matson and DeCabo found that the metabolic switch triggered by fasting, the shift from glucose to fat-derived ketones, is associated with measurable improvements in insulin sensitivity, reduced inflammation, and improved cardiovascular markers. This is not fringe biology. It's peer-reviewed, and it starts happening faster than most men think. Here's why this matters if you're in your 40s, 50s, or 60s. After 40, insulin sensitivity can decline steadily unless you actively fight it. Your pancreas is working harder to move the same load of sugar. Your fat cells are getting better and better at ignoring the signal to let go. The machinery is still there. It just needs the right trigger. I'm not telling you to fast indefinitely, and nothing here replaces your doctor. But stay with me through hour 12, because what your body initiates inside your cells at that mark, autophagy, is the most underexplained process in men's health. Most videos skip it entirely. It might be the most important thing happening in your body that you've never properly understood. The moment you stop eating, a countdown begins. For the first 4 hours, your body is still processing whatever you last ate. Insulin is elevated. Your cells are absorbing glucose. Nothing dramatic yet. Think of it like an airport after the last flight lands. Everything's still running, the lights are on, but traffic is winding down. Around hour 3, blood glucose starts to fall. Insulin drops with it. And here's where it gets interesting. Glucagon, insulin's chemical opposite, starts to climb. Glucagon is the signal telling your liver to release stored sugar. Your liver holds roughly 100 grams of glycogen, enough energy to fuel about 90 minutes of light activity. That's your first reserve tank, and it is now open. A 2018 study in cell metabolism found that early time-restricted eating significantly reduced insulin levels and improved insulin sensitivity in men with prediabetes, independent of weight loss. The mechanism starts here, in these first quiet hours. Your pancreas, by the way, is delighted. It has been firing insulin like a panicked air traffic controller, trying to land 200 planes at once for the last 8 hours. Now, it finally gets to sit down. By hour 6, blood glucose has stabilized at a low, steady level. Glucagon is doing its job. Your liver is releasing glycogen in a controlled, measured drip. You probably feel mostly fine, maybe a little hungry. That's not an emergency. It just feels like one, because your brain has been conditioned by years of eating on a schedule. But here's the kicker. Fatty acids are beginning to mobilize. Under low insulin conditions, your fat cells start releasing stored triglycerides into the bloodstream. Your liver converts some of these into early, low-level ketone bodies, not full ketosis. Think of it as your body warming up the backup generator. The engine is turning over, but the fuel source is changing quietly underneath you. Your body at this point is like a hybrid car switching from electric to combustion mode. You can't feel the transition. But the transition is real, and it has consequences you will absolutely feel by hour 14. This is where the real metabolic shift begins. Liver glycogen is now significantly depleted. Insulin is at its lowest point of the day. Glucagon is elevated, and your body makes a formal decision. It is switching fuel sources. Fat oxidation accelerates. Free fatty acids flood into the bloodstream. Your mitochondria, the small power plants inside every cell, begin preferentially burning fat over glucose. The liver ramps up ketone production in earnest. Let me show you what's actually happening at the cellular level. Your mitochondria are running a fuel quality test, and fat is passing with flying colors. A 2020 study in Nature Metabolism found that fasting-induced fat oxidation measurably increases mitochondrial efficiency while reducing oxidative stress markers in male subjects. Your fat cells, those loyal companions who've been holding on to every gram since the last administration, are now being told to open up. They are not happy about it. But insulin isn't there to protect them anymore. Hour 12 is when autophagy begins in earnest, and this is the phase most content skips entirely. Autophagy, from the Greek for self-eating, is your cell's internal recycling system. Damaged proteins, dysfunctional mitochondria, cellular debris. Your body bags it up, breaks it down, and rebuilds usable material from the parts. Think of it as a cellular deep clean protocol that can only run when the building is closed to new shipments. A 2016 paper in Cell confirmed that autophagy is directly suppressed by insulin signaling. Translation: as long as insulin is elevated, as long as you are eating and digesting, the recycling plant stays closed. 16 hours gives it enough time to actually run a meaningful shift. This process is implicated in reduced cellular dysfunction, slower neurodegeneration, and improved longevity markers across multiple tissue types. The 2016 Nobel Prize in Physiology or Medicine went to Yoshinori Osumi specifically for mapping this mechanism. When someone calls this fringe science, they haven't read the Nobel Committee's press release. Here is the payoff. And it is the one most men over 40 have absolutely no idea is coming. Growth hormone, responsible for muscle preservation, fat metabolism, and deep cellular repair, surges dramatically during extended fasting. A 1988 study in the Journal of Clinical Endocrinology and Metabolism found that fasting increased growth hormone secretion by up to 500% in male subjects over a 24-hour period. The 16-hour mark sits right on the rising edge of that curve. Your body treats growth hormone like a nuclear launch code. It only releases it under very specific conditions: deep sleep, high-intensity exercise, and fasting. All three share one thing in common. They require the sustained absence of insulin. By hour 16, you're running on ketones, autophagy is active, growth hormone is climbing, and insulin is at its floor. This is the metabolic state your physiology was designed to enter regularly. Most modern men, eating from 7 a.m. to 10 p.m., never get close to it. Not once. Not in years. Drop a comment right now. Where are you watching from? And what's the one thing about fasting you wish someone had explained to you sooner? You do not need to fast for days. You do not need to white-knuckle through hunger. 16 hours, for most men, that means stopping eating at 8 p.m. and having your first meal around noon, is enough to move through every single one of these phases. The fat oxidation, the autophagy, the growth hormone curve, all of it. If you want to see exactly how to structure a 16.8 window for men over 40, specifically what to eat during your eating window to maximize each of these mechanisms without losing muscle, that's the next video. It is already up. Watch it. Your body already knows how to do all of this. You just have to stop eating long enough to let it.